boys and girls, welcome to mathematics class. It is good to be with you today. I am Teacher Sarves from Sekolah Menengah Jenis Kebangsaan Chunghwa Confucian. Today, we are going to learn about speed and acceleration. Please have your calculator and notebook with you. We are going to do some calculations. By the end of today's lesson, you should be able to describe the differences between uniform and non-uniform speed, perform calculations involving speed and average speed including unit conversion, explain the meaning of acceleration and deceleration as a rate involving speed and time. Do you know speed is how fast something is moving? The speed of an object is the ratio of distance to time. Distance and time taken are used to measure speed. This was originated from the Italian physicist Galileo Galilei. He defined speed as the distance covered per unit of time. In equation form, speed v equals to distance d over time t. Well, do you know the fastest and the slowest animal? Peregrine falcon has the highest velocity while stooping, which makes it the fastest flying bird in the world. Peregrine falcon has long wings that makes it easier to hunt from a great height and can dive steeply at a speed of over 320 kilometers per hour. Whereas sloths are noted for their slow movement and often related to their laziness. The fastest speed of a sloth is 0.003 miles per hour. Sloths are commonly found in tropical rainforests of South America and Central America, where they live hanging upside down in the trees. Surprisingly, they are excellent swimmers and reaches the speed of 13.5 meters per minute. They use their long arms to paddle through the water. All our daily activities involve movement and speed. We walk, run, and jump, and these involve movement and speed. Boys and girls, can you name some other human activities that demonstrate speed? Great! Some of our daily examples involving speed are swimming, riding a motorbike, skating, and crawling. Now, let's get into our discussion on concepts involving speed. What about uniform and non-uniform speed? Let's have a look at the movement of ball A in the diagram. Consider the ball moving along a straight line. What can you observe? The ball moves 2 centimeters in the first 2 seconds, 2 centimeters more in the next 2 seconds, 2 centimeters in the third 2 seconds, and 2 centimeters in the fourth 2 seconds. In this case, the ball covers 2 centimeters in each 2 seconds. So, the ball moves at an equal distance in equal intervals of time. This is said to be uniform motion. Now, peoples, let's observe the distance time graph that represents the movement of the ball. We could see that the time and distance travelled by ball A are uniformly distributed. Thus, ball A moves at a uniform speed. In our day-to-day life, we come across motions where objects cover unequal distances in equal intervals of time. For example, let's look at ball B. The ball moves 2 centimeters in the first 2 seconds. 1 centimeter move in the next 2 seconds. 2 centimeters in the third 2 seconds. And 3 centimeters in the fourth 2 seconds. What can you say about the movement of ball B compared to ball A? In this case, we can say that ball B moves at an unequal distance in equal intervals of time. Now, pupils, let's observe the distance time graph that represents the movement of the ball. We could see that the time and distance travelled by ball B are not distributed in uniform. Thus, ball B moves at a non-uniform speed. Pupils, let's look at this example. Amin drove a car for 150 kilometers within the first 2 hours and 160 kilometers within the next 4 hours. Did Amin drive the car at uniform speed? Explain. Do you remember the relationship between the speed with distance and time? Yes, great! Speed is the distance over time. Thus, the speed for the first 2 hours is 150 kilometers divided by 2 hours, which is 75 kilometers per hour. Whereas the speed for the next 4 hours is 160 kilometers divided by 4 hours, which is 40 kilometers per hour. Pupils, what conclusion can you draw by looking at the change of speed? Yes, the speed of the car driven by Amin is non-uniform. This is because for the first 2 hours, the speed of the car is 75 kilometers per hour. Then, for the next 4 hours, the speed of the car is 40 kilometers per hour. Now, let's have a look at another example involving speed, distance, and time. John kicked a ball from point M to Q. It passed through N and P. It takes 2 seconds for the ball to move from M to N, which is 1.4 meters. Then the ball moves 2.1 meters from N to P, which takes 3 seconds and another 4 seconds from P to Q, which is 2.8 meters. Did the ball travel at uniform speed? Can you explain? Well, pupils, speed is distance divided by time. Now, let's calculate the values. The speed from M to N is 1.4 meters divided by 2 seconds, which is 0.7 meter per second. The speed from N to P is 2.1 meters divided by 3 seconds, which is also 0.7 meter per second. Now, can you calculate the speed from P to Q? Good! The speed from P to Q is 0.7 meter per second, which is 2.8 meter divided by 4 seconds. Pupils, what conclusion can you draw from this situation? Excellent! The speed of the ball is the same from M to N, N to P, and P to Q. Hence, we could say that the speed of the ball is uniform. Now, let's learn about another concept involving speed, which is called the average speed. What do you think average speed means? Okay, let's look at this example. Ravi started to jog from a park to the foot of a hill at 7 a.m. Along the way, he stopped at a mart to get a drink before he continued jogging. He arrived at the foot of the hill at 10:30 a.m. Can you calculate the average speed of the journey in kilometers per hour? Can you tell me what's the formula for average speed then? Average speed is the total distance divided by total time. First, it is always good to write out the formula as it helps you to understand and remember. Can you recall the formula for average speed that we have just learned? Excellent! Average speed is the total distance divided by total time. Let's try this together. It is given that the distance from the park to the mart is 6 kilometers and the distance from the mart to the foot of the hill is 8 kilometers. Average speed is the total distance from the mart to the foot of the hill is 8 kilometers plus 6 kilometers, which is 14 kilometers. Then divided by the total time taken, that is from 7 a.m. to 10:30 a.m., which is 3 hours and 30 minutes or 3.5 hours. Insert the given values into your calculator. What did you get? Well done, peoples. The answer is 4 kilometers per hour. You are doing great. km represents the distance in kilometers and h represents the hour. Well, what if there are different units? Then you would need to do conversion of units. Let's recall what you have learned on how to convert units. First, you need to know that 1 kilometer is equal to 1000 meters. 1 meter equals 100 centimeters and 1 centimeter is equal to 10 millimeters. Vice versa, millimeter to centimeter is divided by 10. Centimeter to meter is divided by 100 and a meter to a kilometer is divided by 1000. What about the time taken for the movement of any object? The time taken for any movement of objects could be seconds, minutes, or hours. Thus, let's recall how to convert units involving time. 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. Therefore, seconds to minutes need to be divided by 60 and minutes to an hour need to be divided by 62. Pupils, we recalled changing units for measurements and for time. Now, let's do an example before solving problems involving average speed. Convert 160 meters per second to kilometer per minute. 160 meters per second is 160 meter divided by 1 second. As per the unit conversion, remember that 1 kilometer is equal to 1000 meters and 1 minute is equal to 60 seconds. So, converting meters to kilometers, we need to divide by 1000, and converting seconds to minutes, we need to divide by 60. So, it is equal to 160 meter divided by 1000 to change into kilometers, and 1 second is divided by 60 to change into minutes. Pupils, you may use the calculator to help you in the calculation. What's the answer? Good! 0.16 kilometers divided by 0.0167 minutes becomes 9.6 kilometers per minute. Pupils, now it's your turn to solve a problem. Halim cycled to Bakri's house. He left his house at 10 a.m. On the way, he stopped at Amin's house and then proceeded to Bakri's house. The graph shows the movement of the bicycle from Halim's house to Bakri's house in kilometer per hour. Calculate the average speed of the bicycle in meter per minute. Determine the answer using the appropriate unit of conversion. Well, let's check together. Let me show you the working steps. Step 1. Write down the formula. Average speed is total distance divided by total time. Next, substitute with the values derived from the graph. From the graph, the total distance travelled is 2.5 kilometers in 0.75 hours. Keep in mind that the answer must be in meter per minute. Thus, next, convert the units 2.5 times by 1000 divided by 0.75 times by 60. Use your calculators to determine the values. The average speed of the bicycle is 55.56 meter per minute. Did you manage to find the value? Superb job! Boys and girls, you have learned speed and average of speed. Now, let's investigate the rate of change of speed. This is called acceleration. Look at the movement of the ball. If we drop a ball from the top of the slope, the ball rolls down fast and the speed increases, right? Well, then what would happen to the change of speed? Yes, the change of speed increases too, where the final speed is higher than the initial speed of the ball. In this situation, the rate of change in speed is negative and we called it acceleration. Pupils, now we need to think, when would the speed of the ball decrease? Now, look at the movement of the ball when it is pushed up the slope. What would happen to the speed of the ball when it reaches the top? Yes, pupils, the change of speed of the ball decreases as it is moving against gravity, where the final speed is lesser than the initial speed of the ball. In this situation, the rate of change in speed against time is negative and we call it deceleration. From the observation done, we can conclude that the increase in speed results in acceleration and the decrease in speed results in deceleration. Therefore, acceleration and deceleration are rates that involve speed and time. Now, let's determine whether there is acceleration in the following situations. Situation 1. A plane is traveling at a constant speed of 1,200 kilometers per hour. Situation 2. A motorbike is traveling at a constant speed of 70 kilometers per hour. Students, can you guess in which situation acceleration is involved? Well, in both situations, the objects are traveling at a constant speed, where the change of speed would be 0 kilometers per hour. Therefore, both situations do not represent acceleration. Hence, there is no acceleration in both situations. It's your turn now to solve this question. Given that an object accelerates from a stationary state and reaches a speed of 25 meters per second in 5 seconds. What is the acceleration of the object? I'm sure you can do this. Let's write this out step by step. Recall the formula for acceleration. Yes, acceleration is speed divided by time. Now we substitute what is given. Speed is 25 meters per second as the final speed minus the initial speed, which is 0 meter per second. Therefore, acceleration is 25 meters per second divided by 5 seconds. How do we get the unit for acceleration? You are right. We derive the unit for acceleration by observing that the unit given for speed is in meter per seconds and time is in seconds. Thus, meter over second divided by second is equals to meter per second square. Hence, the acceleration of the object is 5 meter per second square. Pupils, now let's look at this question. A car moves from a stationary state and accelerates uniformly to reach a speed of 160 km per hour in 34 seconds. What is the acceleration of the car in meter per second square? How do we solve this question? Let's do it together. What is the change of speed of the car? Correct. The change of speed is 160 kilometers per hour minus 0 kilometers per hour, which is 160 kilometers per hour. Remember to write the formula first. Yes, acceleration is change of speed over time. How do we change the units? Well, the speed is 160 km per hour, which is 160 times by 1000, and per hour is 60 times 60. Peoples, use your calculator. Yes, we will get 44.44 meter per second. Given that the car accelerates in 34 seconds, hence time is already in seconds. Now we can substitute the values in the acceleration formula. Acceleration is 44.44 meter per second divided by 34 seconds. Thus, acceleration of the car is 1.307 meter per second square. Excellent! You are doing great! Well, do you remember what is acceleration and deceleration? Let's do a quick check with the following question. A Grab food rider was riding a motorbike from a restaurant to a customer's home at a constant rate of 60 meters per second. Upon reaching the customer's home, he applies the brakes and the motorbike moves slower at a uniform rate until it stops in 30 seconds. Can you determine the acceleration of the motorbike? Peoples, can you check the change of speed first? You need to understand that when an object stops, then its speed is 0 meter per second. Right, therefore, the change of speed is 0 meter per second minus 60 meters per second, which is negative 60 meter per second. The next step is to write down the formula before substituting the values. Acceleration is change of speed over time. Next, we can substitute the values given. Acceleration is equal to negative 60 meters per second divided by 30 seconds. Good, the units are the same, so we can find the values now. Negative 2 meters per second square. Therefore, the motorbike decelerates at 2 meter per second square. Great job! You are good at solving problems involving acceleration and deceleration. Boys and girls, we have come to the end of the lesson. Now, you are able to explain the meaning of speed as a rate involving distance and time. Describe the difference between uniform and non-uniform speed. Lastly, you are able to perform calculations involving speed and average speed, including unit conversion. I hope that you have enjoyed today's lesson. Thank you very much for your attention. Goodbye.